Hey everybody, it's Jessie again. This is a very quick video to help you with Chapter 9, Part 2 exam. I ran through the rest of your Chapter 9 exam, and I feel like if you're doing the practice problems in the book, you should be successful on the exam. There's one that's a little bit trickier. I want to give you a great example of how that works, and I also want to tell you that MLP does not have the right answer, so it's going to tell you you're wrong even when you're right. So just ignore it. Okay, my example is, let me pull it up, sorry. How many grams of salt, let's use sodium chloride, how many grams of sodium chloride do I need to depress the freezing point of 1 kilogram of water, let's say 3.2 degrees. C. Okay. Everything that I need to solve this one is on page 355 of your book. Here's a little table that tells me how 1 mole of solute added to 1 kilogram of water will change the freezing point by 1.86 degrees C. It would change the boiling point by 0.51 degrees C. We're talking about freezing. Okay? And the equation that I need is right here in this example problem. Temperature change is equal to the number of moles of my salt and a mole-to-mole relationship for the number of moles of salt and then how many moles of solute particles I get out of that. So how many ions dissociate out of my salt? In the case of calcium chloride, it would be 3 because I would have 1 calcium and 2 chlorides. In the example we're using, it's 2 because we have a sodium and 1 chloride. Okay, and then for every 1 molecule or every 1 mole, it changes by that 1.86, right, that we saw from our table. Okay, so setting up our equation. Delta T is equal to number of moles of NaCl, and for every 1 mole of my salt, I'm actually going to get 2 moles of solute, right? That's 1 Na plus and 1 Cl minus because it dissolves. So I end up with 2 species instead of just 1. And for every 1 species, it changes by 1.86 degrees C, by a negative. It goes down. Okay, so let's plug in what we know. We know delta T is negative 3.2 degrees C. It went down by 3.2. Number of moles is what I'm looking for, right? Well, I'm looking for number of grams, but that's what I want to know. Number of moles, I can get to grams with my atomic weight. My mole-to-mole relationship, 2 moles. And again, times that, negative 1.86 degrees C. So if I solve for my number of moles, bring my 2 over, bring my 1.86 over, and I'm in number of moles of NaCl, which is equal to Oh, I accidentally threw my little calculator on the ground and broke it. So I'm going to use my Excel here for you guys instead. Just blank that out. What do I have? Is equal to negative 3.2 divided by negative 1.86 and also divided by 2 is equal to 0.86 moles of NaCl. And then how do I get to grams? With my atomic weight, which I'm going to look up really quick. Looks like sodium is 23 plus 35.45 would be 58.45? 58.44. How do I do it? 22.99. And I want to be in grams. So if I go times 58 point, what did I decide on? 0.44 grams per mole. My moles cancel. And I am going to get 50.3 grams of NaCl. Now again, if you put in your answer like this isn't exactly the problem, but I've given you an exact example. MLP is going to tell you you're wrong because they forgot their all-important mole-to-mole relationship step. Okay? Good luck. Holler if you have questions. I am here. You have my phone number. Let me give it to you one more time. It's 307-399-4776. Write it down again. Okay, guys? Good luck.